Last but not least, we have Nick Coubray, CEO of Howick. Nick is the driver in the company's pursuit of innovation. By the way, I wrote this, just so you know. He is the third generation of the Coubrays to champion this family-owned business and has been involved in framing technology and industry development since his late teens. After earning his stripes on the shop floor, assembling machines and sweeping the floor, Nick went on to head Howick's UK office for 7 years, laying the groundwork which established the UK-Europe as Howick's largest export markets. He has also spent significant time with US-based customers and has taken the lead in a number of collaborative R&D projects, which eventually became customer feedback-led standard features across the industry. Nick has developed a deep understanding of the global construction industry and technology across Howick's global user base, from simple construction projects to high-tech installations. His focus is on driving Howick's team to continue to evolve technologies for better building and advocating for more efficient and sustainable construction practices throughout the industry. And also this event is his brainchild and his idea, and the speakers that we've got and the ideas he's got, like who should be talking about what, that's all Nick, by the way. I give you Nick Coubray.
Thank you, Cindy. Yeah, so as I mentioned early on, was that there is not that much innovation in construction, but there's a lot of innovation in this room, and that's really the challenge we're facing a lot. The innovation's there, but it's getting the end clients and everybody else moving forwards in the right direction together. So I wanted to take a bit of time to talk about a new product that we actually tried to launch in the end of 2019, which is the worst time to launch a new product, where we have to be traveling around the world showing people how it works. So we've developed a product which we've called the Extender, which is a telescopic stud system. So the idea behind this was we started off very early on with trying to go into buildings and fit studs to it, and we were working to 0.5 millimeter tolerances, and everybody knows the buildings are not built to 0.5 millimeter tolerances. We're talking to people about inches and sometimes feet. So the first process was to go in and laser scan everything, and that works, but there's a big cost to that, and then you go to design it, and then you show up on site and someone's screeded the floor and it doesn't fit. So we sort of stepped back and said, how do we solve this problem? How do we solve the problem of that we're super accurate but nobody else is? And they don't actually want accuracy, they just want speed, and they want something simple. So I'll skip around a bit because the presentation is quite long and I'm trying to shorten it up. So we developed a system that made of 3 components, a C stud, an R stud, and a U track. So those 3 components fit together in different combinations to allow us to build a panel that we can adjust the size of. And within reason, it can be any size, but in reality, we're limited in the respect of either you've got to have a certain overlap for structure, and then you've also limited by where you put screws and openings and other holes. So we basically came up with 3 common panels. So we had a customer come to us and he wanted a stud that slid. And we said, hang on, let's step back from this. We can make a panel that slides. And then we thought about, we can make a panel that slides in 2 directions. Hang on, no, we can make a panel that slides in 3 directions. Because the floor's not level, but the roof won't be out of level as much as the floor is in most cases. So this starts. Okay, animation's not working. All right, so I'll talk about 3 projects, or 3 types of projects. The first one is wind over construction, and Amir is here from Boston, if anyone wants to talk to him about this particular project. We did a Westfield shopping centre in New Zealand, which was our very first project. And then we've done a couple of projects in Wellington in New Zealand and Rondo in Australia, who's part of the CSR group, have taken on some of our machines and are using them in Australia. And everybody's using them differently, so it hasn't really got to a standard process yet. So this project in Boston was one of the very first ones we did, and it was quite interesting. It's a 100-year-old building, and at the peak of the pandemic, so no one could travel. So the team from Windover went in and laser scanned the building, and that was our starting point. We sent the machine to the Autodesk Technology Centre and installed it remotely over the phone. The guys from Windover did the scanning and all the design work. Then the team from Struxsoft in Montreal did the design of the panels. The team at Autodesk's Technology Centre workshop crew actually made the parts on the machine and put them on a truck that then went to the site. So you can just see the machine here. It operates pretty much the same as any of our other standard machines. You can make standard panels, but then you've got these added features that you can make these telescopic panels. So you can see the guys putting them together here. Very simple. The two pieces just slide together, which gives us our telescopic, and the screw holes on the side allow us to fix the positions off once it's in place. So it doesn't really take much room. It's all done on the floor in this respect, but typically in a factory you're going to be working on tables. These guys had worked with standard panels, but they'd never worked with anything like this before. So again, a little bit of phone support, some late nights, it worked pretty well. So installation process, again, these guys installing these had never seen these sorts of panels before. And it just sort of shows how easy it was. Again, with the mayor and the team, we discussed how they were going to work, how much compression we could get in them. The key points being we can take it in the lift. So we've done some hospital projects back in New Zealand where the issue is they can't shut the building down. They can't have noise, they can't have dirt, they can't have waste. And those things are just solved by this as kind of a byproduct of what we were trying to achieve. So very typical for the retrofit market. Otherwise, you've got guys with a big bundle of studs, chopping and cutting and hacking, and you're relying on them to get the spacings right. So we can set the spacings within standards. You know, things like the sills and that, it just makes life easier for the installer. So you've got two guys running around this site putting all these panels on. And we take into the site, we don't take anything out. There's nothing to take out. So first project we did was Westfield Shopping Centre, and it was quite a big undertaking. They were 3 months behind on the project when we made the first panels, and they managed to get the project back on track by the end of the job. What they found with that particular project, if I go back to it, they did basically partition walls for the shopping centre. They did soffit panels where they bolted them to the roof and then pulled them down to a laser level. And through the process, something we didn't think about, but 90% of the panels were identical. And then 10% were made to adjust to suit the funny shapes of the building. This project is another one we're doing in New Zealand. It's a 16-storey apartment block. It's a conversion of an old building. There's 11 stories of it, have our framing in them. And we can just see some design of the 3D there. So this project was a mixture of panelised and flat pack. And we made all the panelised panels up in our factory in Auckland and shipped them to Wellington, so equivalent of going from here to Edinburgh. So a bit of remote working. You can see some panels in place here. What the client found is that their installation times were the massive savings. So when we did flat pack, they saved 50% on installation time. When we did panelised, they saved 75% on installation time. And it wasn't just the time on site, it was the number of people reduced too. So they effectively had crews of 2 on each floor, and we were doing 3 or 4 floors at a time. And they came in straight into the site, straight into situ, and they had a little staging area. Because Wellington, a bit like London, there's no parking. Another project that's come out of this that we're doing at the moment is the Rail Control Centre in Wellington as well for the same client. So existing building, they've designed this great curved structure that they want to put in, so we can not only telescope, but also using some of the stuff that Scott's developed, we can curve it as well. So it's a really flexible product, but that design piece at the start is the key to it, but not so much as it would be if it didn't telescope. So Rondo in Australia, another example. So Rondo took on our machines after their customer who builds the Westfields said, we have to have this. Everything we do from now on is this, or we're going somewhere else. So as a big customer, they said, right, we need some of these. This particular project is flat pack, so all the bits came in as a kit of parts. And this is something we kind of face, which you'll see in this video, is we start with new building companies. They can't get their head around the concept. So let's go simple. Let's go really right back to simple. We'll make a panel that's 3 meters long. And this one is studs at 600, but we can do the studs whatever we like. And it's made up of studs and new tracks. The studs can compress anywhere from 1.9 meters up to 3.2 meters. And the concept behind this is we're selling you a wall. We're not selling you studs. We're not selling you meters of steel. We're selling you a 3 meter wall that you can snip and cut if you need to make smaller wall. So stage one's this. Stage 2 is then how do we use this and make doors and window openings and the like. And that's where that kind of 10% piece comes in. The majority of panels are these. And the reason we went 3 meters too is it fits in the back of a van. So the contractor who's doing a shop fit out could have half a dozen of these in his warehouse. He grabs one, he takes it to site and puts it up. And the installation process is literally that quick. So again, Rondo then took it to this is another project they're doing where they're doing all the panels on the roof. So the panels were assembled on the floor, lifted up on the boom lift, and just finalised into place before they did the final fixings. So these things started to grow, and then the next one was double T concrete slab. Now, anyone who's ever worked with those will know that to fire stop them was an absolute nightmare because you have to get the framing to fit inside those gaps. So we made these sections that you see here that are about 2 meters long as a piece, and they're all telescopic in every direction. Again, up on the scissor lift, push it into place, seal it off, and it was a 2.5 minute install versus where they're telling us they're 45 minutes to an hour normally. And then on top of that, which is a little bit hard to see here, but we made a telescopic panel underneath. So we put those to the roof and then we use the telescopic panel to seal to those. So we're doing a lot of these at the moment for the customer because it's just so easy for them. Again, it's a standard kit of parts because those double Ts are within reason, within a tolerance, and we know we can cope with that. So that's kind of the telescopic thing that we've done. Some other projects that we've been working on, and you would have seen in Nicola's presentation, the other building we're working on. So one of the things we keep getting asked about is coil loading. Coil handling is a major issue for everybody because of health and safety. So the first generation system we made here for loading came from the requirements of customers who don't have cranes, and fork trucks are just dangerous, but that's what most people use. So we started with a system they can load their coils on, and basically it's a human-controlled robot to drive it. Automation will come shortly after. The next gen one that we've started to do is, because we do machines, we do different gauges and different material thicknesses, so, and tipping a coil is also an issue. So the coils will generally arrive, as we call eye to the sky. So we tip it up, we then pick it up with our robot arm, and then place it in the stillages. So this particular unit can hold up to 30 tonne of coil, which would be 2 or 3 days production for most people. So they can come in, load it all on, and then load it into the machine. Or if you've got a machine that does multiple sizes, you can have multiple coils stored and ready to go. So this is something that's in development that we're talking to quite a number of customers about at the moment, as to how it fit in their factory, because it has to be modular and because the orientations might be different for different factories, because no two sites are the same. And usually when people are thinking about this, they're 99% through the way of designing their factory, or machines are already in place. So that's something we're working on. The big heavy building we were talking about before, so this is the building's actually going up now. They're partway through it. So that's half the building on the truck. So we're doing 2 truckloads for the whole building. This one is 26 metres by 48 metres. It's got a single small column in the middle. It's possibly a bit over-engineered because it's the first one, and we really struggled to get it through the council consent process because it's we've never seen it, we want you to test it. So that was where all this FEA came in, because we couldn't build a building and test it, so we had to prove to them that, look, we think it's going to work, this is how we're going to work. The team from Brydenwood did a lot of work on this for us, and then we engaged with the local consulting engineers and said, here, spoon feed it to you, this is the idea, this should work. We're going to build one anyway on a farm and try it. And that led to this building up. Not the best photos, but they were to that point within 2 days of arriving to site. So that's half the building stood. So they're hoping to be a 5-day process to the point where they're cladding it. Now, the beauty of this is we can make them any length, any size, very little waste, because it's only the cut-offs and punchings from the machine. And again, they all go back to the mill for recycling, which is great, and we control that at that process. We see huge opportunity for this because we started talking about this probably 10 years ago. People wanted to do indoor tennis courts and horse riding arenas. And I thought, how can we do it without hot rolled? The idea with that particular machine is it's small enough it can fit in a 40-foot container, so we could take it to site and you can run a 28-metre beam on site and assemble it with battery tools, and you can use the high ab on the truck to stand the building. So it's just thinking a little bit outside the square, and it's something that we like to do, and we like to work with clients that want to do that. And we're always a bit far removed from it because we're the machinery designer, and we're good at machinery. We kind of understand buildings, and we've got great ideas of what we think we could do with buildings, but then we have to work with good engineers that can actually sit back and say, okay, it doesn't meet the building code, it's strong enough, now how do we get it across the line with building control? So using that same technology, we started to play around with modules, and we thought, well, how can we build a module without hot rollers? Because they've all got hot rollers. So this was our little prototype we made, and using our rivet connection technology, we actually rivet the roof panel and the floor panels into the main structure. So it becomes basically a monocoque box with all the bracing and everything all in the one piece. The other unique thing we can do with the rivet is we can actually clad the panels and then rivet the steel to the steel. So the panels are partially clad where they need to be and then finish them. So that's something we're playing with. We've got to find the right client to work with for that. And the problem is the prototype machine's in New Zealand, and it's not really something we can ship somewhere else in the world. So finding a modular client in New Zealand is not easy. The final one I just want to point out is something we get to do quite often is a bit of concept design. So we keep getting people asking us about ventilated battens. And we get 10 customers come in with 10 different designs that all need certification and testing. So what we tried to do is come up with a design of one that we can make multiple different battens out of the same machine with a few variations. So we do a horizontal version and a vertical version, and we do 2 different depths. And we do punched and not punched. The idea with that is if we can get a group of people together that basically want the same product, because there's not enough volume for someone to go and test that by themselves, that we can split the cost of that engineering and that design and all the testing that goes with it, and then basically they can pay a tenth of it and they get their machine and off they go. And it's something we find in the industry is really hard, is everybody wants to put their stamp on something, and it's a product like this is, while it's important that it's right, it's not important that everybody's got their own different one, because it makes up less than 5% of the building structure. So that's one of the things I really want people to try and think about, but it's quite hard, especially when you're dealing with really big companies. It's ours and we want it, and no one's going to share it. So we like having discussions with lots of people and sharing those sort of ideas and saying, well, you know, yes, it's your idea, you want to do it, but did you know there's 10 other people who've asked us for the exact same thing yesterday? So I won't stand in the way of the drinks and food, so that's my presentation. If you've got any questions, I'm happy to answer them either now or later.
Thank you, Nick, for the presentation. It's really impressive, very interesting. I have a question on the warehouse project you did. In terms of structural analysis, what tool did you use? It looks like you do this kind of, you do the structural analysis on every single connection detail.
Yeah, so it was. That's why it took a long time. So we initially thought it was going to be 2 weeks. I think it was about 10. So
what software was it?
I don't know, do you know, Nicola?
It was a combination between robot and e-taxi.
Interesting to know, because we're in the process of developing integrated kind of engineering, so when you design something, put the load, wing load, everything, actually it gives the answer what sort of like steel frame system, the density, the bracing details. So interesting.
I think the next step from that too, just touching on that design, is that we looked at just the portals, because that's what was required. And we think we can pull a lot of mass out of that building by actually looking at the building as a structure and actually looking at each portal as a bay and looking at how do we brace the bays and then looking at using the cladding as part of that as well. But that's a big next step. And a lot of the councils, especially in Australia and New Zealand, they don't want to know about this whole structure of the building. They just want to know just that bit, tick a box.
Just a quick follow-on question. Is there what is the limit you can go to in terms of ease height at sheds?
It really depends on the section. So we can change the section size, we can change the rivet size to go as big as we want. We looked at doing those rivets 40 millimetre diameter, and they give us about 120 kilonewton shear on that section. So we could actually go to a 4-inch rivet and probably, instead of a 150 deep section, a 300 deep section. We did some initial design up to 50 metre clear spans, which were getting big, but they were still doable. So it really just depends on the engineering and the actual structure and design.
I don't need the microphone. For your load-bearing walls, you can use those telescopic studs.
So normally for load bearing, we wouldn't use them as telescopic, but it's really just a function of the connection. So we're using self-drilling screws through those holes. You could potentially use something like a self-piercing rivet, which is a bit more secure, to put them back to load bearing. And we get asked that quite often about facade systems because they need to carry more load.
That's it.
Yeah. So what's the maximum gauge you can run through?
For the big truss section or for anything. Typically we go up to 3.2 millimetre as a max. We prefer to keep it to 2.8 if we can, just to reduce the loads. And we tend to think we'd rather put an extra stud in than go to a heavier gauge because it just becomes harder to manage.
I am from Czech Republic, from Prague. I would like to thank you, Nick Coubray, that he has a patient with me, Alexander Bory. You remember, we cooperate with company now, and it is very difficult in Eastern company to present LGSF system like I have possibility to see it, and I very appreciate it that I was invited and I can come back and show what's it going really on LGSF systems around the world. Thank you very much.